Hello, everyone. Welcome to our live stream. So this is gonna be our not only our YouTube live stream, but our first Facebook live stream as well. So thank you all for coming. Uh, well, to so mine is so for starters, my name is Saul Rivera. I'm one of the public program specialists here. I mostly help with guided tours, translations, and live streams such as this. I'm also joined by my colleagues Julie Meyer and Joe Wheelock. Yep, and
Morning.
Julie, Joe, tell us a bit about yourselves.
Oh, I thought I was going to get away without having to do that. I'm Judy Meyer. I work here at McDonald Observatory. I've been here a little over 20 years. I am a K-12 program coordinator, and I do all kinds of different things. Every day is a new day, and every day is fun. And Joe.
Yes, I'm Joe Wheelock. I work here in public programs, star parties, guided tours, solar programs, K-12 activities. I've been here for a little bit longer than Judy. And yeah, glad to have all of you here today.
Yeah, and they've both been here a lot longer than I have as well. Yeah, so thank you all for joining us for the stream today. So for those of you, if this is your first time joining in one of our streams, there will be feel free to type into the chat if we ask a question. Especially if your little ones are watching and have a question, they are more than free to type them into the chat. We do have a moderator in the chat that is wait, got a bit little train got a bit lost there. We do have Mara in the chat that can answer any of the questions, and also will pass them along to us so we can answer them on the big screen. And for stars, Cav, so want to talk about where we are. So we're at the McDonald Observatory, which is a current active research observatory in Texas. We're in far west Texas, so even though we're part of the University of Texas at Austin, we're all the other way on the other side of the state. So basically, if we want to get to El Paso or Midland or go to Wallerburger, we gotta drive 3 hours to get there. We're really far away. And it's very good for us for astronomy because if you're far away from people, you have less light pollution, darker skies. We're in the desert, so we usually have clear weather. Sadly, today may not really that much of the case, but on average, we usually do. And also it's really nice out here. So where currently the three of us are currently located at, we're near our visitor center. So here's a pretty cool picture of like the layout of the observatory. Where the red arrow is our Moody Center, our old visitor center. And this is where currently Joe and Julie are at. And I'm not there. I'm basically just like a little bit farther back at them at my own house with my own setup here. But we're all basically
You're
pretty close
still
to each other.
behind that arrow, though.
Oh yeah,
Yeah,
that is true. I'm
you're
still
behind the
technically
arrow.
by where the arrow is, just hiding behind the arrow.
Hiding behind the arrow.
Yeah, and today we'll be talking a lot about the sun and eclipses and such because there's some really cool eclipses coming up. Before we talk about the eclipses, Joe's going to talk a bit about, well, the sun itself. What is the sun? What's going on with it and similar?
All
Yeah,
right,
where to
thank
you,
you.
Joe?
Thank you, Saul. Let me bring up my slides here. And here we go. So here we have some quick facts about the sun. The sun, it is made up mostly of hydrogen, helium, trace amounts of other elements, has diameter of 865,000 miles, and it's about 93 million miles away from the Earth. Estimated age of the sun is about 4.5 billion years old. Now, the temperature of the visible area of the sun that we see called the photosphere is around 10,000 degrees Fahrenheit or so. Now, the sun, it is a little diagram here for you. It keeps the sun into its spherical shape. You have two things going on. Whoops. We have You have gravity and you have gas pressure. The gravity pushing in, gas pressure pushing out, kind of a balance of the two. Have a fancy name for this. It is called hydrostatic equilibrium. I love that word, hydrostatic equilibrium. One of my favorite terms there. So, all right. So I mentioned the size of the sun, 800 365,000 miles across. So here we have a picture of the sun. So knowing that, how many Earths do you think would fit across the sun? In other words, how many Earths do you think the sun is compared to the size, or how big do you think the sun is compared to the size of the Earth? If you know the answer to that, type that in the chat. So let's see if we have some guesses here.
Yeah. Even if you don't know the answer, feel free to drop in a guess.
Take a guess. Give you a second here. There may be a delay. Here we go. 10,000.
That's a great guess.
That's a good
Yeah.
guess. A
A
bunch.
bunch.
Okay, that's a fair guess.
That's correct.
80?
Ooh.
Ooh, we got a really good
Close.
range going on.
Yeah, okay.
So it's something between 10,000 and 80, maybe?
Exactly. Yeah, so 80 is pretty close. 109 Earths would fit across the sun. Second question for you. How many Earths do you think might fit inside of the sun's volume? So think about that. Any guesses for that? Give it a minute here.
We need that Jeopardy theme music to play.
Yeah, the Jeopardy
Yeah.
music.
And the little TikTok thing.
Here we go.
1 million?
1 million. You know, that's really close. About 1 million Earths, a bit over 1 million Earths would fit inside of the sun. For scale here, the planet Jupiter. Jupiter is 11 times the Earth's diameter. You could fit 1,300 Earths inside of Jupiter, and 1,000 Jupiters would fit inside of the sun. So the sun, it's pretty big, right? Compared to other stars, not so big. Here we have 4 different stars compared to the sun. Antares, Betelgeuse, Aldebaran, and Rigel. You can see in this picture, they are much, much bigger than the sun. On the other end of the scale, we have smaller stars. Now, some of the smallest known stars are called red dwarf stars, about 1/10 the size of the sun, the mass of the sun, not much bigger than the planet Jupiter. In fact, the closest star to the Earth besides the sun is a red dwarf star called Proxima Centauri. It's about 4.2 light years away. So 1 light year, that's how far light travels in 1 year, is about 6 trillion miles. So Proxima Centauri is maybe 26 trillion miles away or so. In fact, it's part of the Alpha Centauri system. Now, you cannot see it, unfortunately, from Texas, but you can see it from the Florida Keys or maybe Hawaii. Best view of this would be from the southern hemisphere. So a bit about some of the different sizes of stars compared to the sun. When you go outside at night and you look up at a beautiful night sky if you're far away from city lights, you might notice that stars have colors. Right, so why do you think stars might have colors? Type that in the chat if you think you might know the answer. Give it a minute here. Could be some delay.
Well, Gabby has no idea.
That might have been from a previous question, but I don't know.
Yeah, that was from a previous question, I believe.
Uh-huh.
But either way, it is still a good guess.
It's a good guess, right? No idea is a good guess. Different star materials.
Ooh, yeah.
That's
good
pretty
guess.
good. Types of
Different
gases.
Type of gas and speed of movement.
That's a good
Well,
guess, too.
speed of
Yeah,
movement.
all right. Well, let's put up the answer here. Stars have colors because of their temperatures, right? So blue stars are hot stars. Think of a blue flame on a gas, a stove. Your oven, for instance, its temperature is what? 400 to 500 degrees Fahrenheit. Don't want to get it too hot. You don't want to, burn your cake or whatever you're baking in your oven. And then the cool stars, relatively speaking, are around 5,800 degrees Fahrenheit or so on the average. Hot stars, perhaps 54,000 degrees Fahrenheit. Sun averages, it's about 10,000 degrees Fahrenheit, like I mentioned earlier. So that is why stars have colors, because of the temperatures, and we classify them by their temperatures. And you can see the classification scale I have on the screen here. O stars are the hottest stars, go down to B and A stars for less hot, get into F and G type stars, a little less hot, and then the K and M stars for the cooler stars. All right, so that's a bit about our nearest star, the sun, and how it compares to other stars. I'm going to turn it over now to Judy, and she's going to talk to you all about eclipses today. So Judy, take it away.
All right. So, in case you haven't heard, there are going to be some eclipses happening in the next 6-7 months. Anyway, between now and April of 2024. And we're in Texas. And so I'm just showing you the map of Texas right now. We'll get to other maps after a while. But you can see on this map 2 paths for 2 different eclipses that are crossing Texas. And the one that we're very excited about that's coming up very soon is the one on October 14th. And that's the path that comes into Texas from New Mexico, crosses through that X area that's got Fredericksburg and all the places that are going to be full of visitors in April. Anyway, and down through Corpus Christi. So West Texas to South Texas get a pretty good eclipse. So I want to talk about what an eclipse is. And really, before I talk about what an eclipse is, I got to talk about a couple of things, because as an actual solar scientist explained it to me, this is the technical stuff. Things go around things and things block things. So that's all you need to know about eclipses. Okay, not really. So let's do this. If I held up that's not a pencil. If I held up a pencil and let go of it, it would go down toward the floor, right? How about if I was standing on the North Pole with a ball and I let go of the ball, it would go down toward the Earth. But if there was a hole in the Earth, that ball would go, oh my goodness. Some people might tell you the ball would go all the way through that hole in the Earth and land on your floor. But we know that the Earth, it doesn't work like that. And so, if you're not a very small child, a kid might think that. Most adults have the idea that the ball is not going to come out the other side and fall into whatever pit is underneath the South Pole. So let's think about this a different way. Yeah, that's not what the ball is going to do. Oh goodness, you don't want to see that. I'm just going to, if I'm standing on the North Pole and my friend is standing on the South Pole and we let go of our balls, they're both going to go toward the center of the Earth. And eventually those balls will come to rest at the center of the Earth. Now that's sort of a crazy thing to think about. How about this? How about if I take my ball and I throw it? I throw it forward. It's going to go forward a ways and then it's going to fall toward the center of the Earth. If I throw my ball even harder forward, it's going to go forward and it's going to fall farther, but it's going to fall toward the center of the Earth. But if I could throw my ball super, 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 super hard, if I had a better arm than I would ever have in actuality, if I had the best throwing arm of a rocket arm or something, and I threw the ball, it would go forward and it would fall toward the center of the Earth, and it would miss, and it would keep missing and keep missing and keep missing until it hit me in the back of the head, and I would fall over, and the ball would keep going around and around and around and around the Earth. And what we call that is an orbit. So that ball that I hit with so much velocity forward is in orbit around the Earth. Now, that ball's in orbit around the Earth, and that's great to know, but what's that got to do with the moon? Guess what? The moon is falling. Joe, what's it falling toward?
It's falling toward the Earth. The center of
Yeah,
the
what part of the Earth?
The center of the Earth.
The center of the Earth. And
Yeah.
what's it doing?
It's missing.
Thank goodness, right?
It's missing.
Hey,
Yes, exactly. Yeah.
what's the Earth doing, Joe?
Well, it's falling toward the center of the sun and missing, thankfully.
Thank goodness, yeah. So we can think of the moon as falling toward the center of the Earth, but having enough forward velocity that it's missing. So that's what an orbit is. But as the moon goes around the Earth, we can see different views of the moon. And this is a set of pictures from the Goddard Space Flight Center. No, the Jet Propulsion Laboratory. And this is one of their staff people demonstrating a really nice way of thinking about moon phases. So in this picture, this model is holding up a ball, and the light is coming in from the left side of the screen, and it's shining on the ball, and it's shining on our volunteer's face. And we can say that her head is the Earth and her ball is the moon. And what she sees is, since everything's coming in from the left, she's looking that direction, what she sees is that the part of the moon that's facing her isn't lit up at all. And that's the phase of the moon that we call the new moon, okay? And as the moon moves around the Earth, so we're going to move the moon around the Earth, what she sees is more and more and more of the moon is lit up. So we go around and we see first quarter moon when the moon's a quarter of the way around the Earth, a little farther around, gibbous moon, and then we get to full moon, where the part of the moon that we see from the Earth is totally illuminated. We had full moon yesterday. So yesterday, if you saw the moon, you were seeing that the face of it facing you was totally illuminated. And as the moon continues around the Earth, we see the waning phases, waning gibbous, last quarter moon, the waning crescent moon, and then back to new moon. And one of the things that you might think is that during new moon, maybe the moon is casting a shadow onto the Earth. And it turns out that happens sometimes, but not all the time, because the moon's orbit around the Earth is slightly off kilter with the Earth's orbit around the sun. So the sun, moon, and Earth are not a totally straight system all the time, but they cross each other at a 5-degree angle. So sometimes the moon casts a shadow on the Earth. When the moon casts a shadow on the Earth, that is what we call a solar eclipse, because the moon appears darker on the Earth. So the moon casting a shadow on the Earth is a solar eclipse. And let's see. So if we go forward one, now I want to show you just a really quick little video clip, also from the Goddard Space Flight Center. Here comes the video. Maybe. It's coming.
Okay.
See? It's coming.
It's on its way.
Yeah. Okay.
Let's see. Shows it's playing.
There we go.
Oh,
okay.
There we go.
It's loading. Here it is. Okay.
Okay. Well, I want to start back a little ways. Yes, it's playing. So what this is showing, what it would be showing, is that as the sun shines on the moon is casting a shadow onto the Earth. And this is showing the path of the total solar eclipse that crossed the United States in 2017. And here we see the sun and the moon, and the part of the shadow of the moon that's the darkest where is called the umbra, and the part of the shadow of the moon that is less dark, that's called the penumbra. And if you're under the umbra, then you are able to experience a total solar eclipse. Now we're going to go back to our slides and make that movie go away. And I just want to talk about different kinds of eclipses. So there's that nice picture that shows the sun shining on the moon casting a shadow onto the earth. And you can see that cone of umbra, the darkest shadow. But let's move forward a little bit. And
let's see.
Okay, one more slide. So here's a diagram. This is not to scale. The Earth is not that big compared to the moon, and the distances are not that short, but this way it all fits onto one slide. During a total eclipse, the moon casts this little umbral shadow onto the Earth, but the eclipse that's happening in October happens when the moon is just a little farther from the Earth, and so it appears a little smaller in the sky, and we don't get that entire shadow onto the Earth. We get what we call an antumbra shadow and a penumbral shadow, but we don't get the umbral shadow. So nobody's going to experience a total solar eclipse during the eclipse event that happens in October. But we will see something very, very cool. So partial eclipse happens when the sun is partially covered up by the moon, obviously. Looks like the sun's had a bite taken out of it. An annular eclipse is the one that's going to happen in October. And with an annular eclipse, the moon is a little farther from the Earth. It's smaller in the sky, and it doesn't totally cover up the sun. So you get what we call an annulus. That's a fancy name for a ring. And you may have heard this eclipse called a ring of fire. And then there's the total eclipse, total solar eclipse. We expect one to happen in April of 2024. And we'll talk a little more about that when we look at the maps. But then there's one other type of eclipse, and that's the lunar eclipse. And a lunar eclipse happens when the Earth casts a shadow onto the moon. And we just like to talk about that just because it's another kind of eclipse. That's not what we're going to be experiencing. That's not really what we're here to talk about, but those are some pretty pictures that were taken by our friend Joe. So there you go with the lunar eclipse. Let's see what I think. The next thing I want to show you is a couple of maps of eclipses, and then we're going to go to Seoul to look at the big eclipse, the interactive eclipse map. So here is a map that shows the path of 3 eclipses. The narrower path that goes from Oregon to the Carolinas, that's the 2017 eclipse that you may have already experienced. And if you experienced the 2017 eclipse, feel free to talk about it in the chat. That would be very awesome. The annular eclipse that's coming up in October is the one that comes from Oregon down through New Mexico and across Texas from the upper left to the lower right. And then the total solar eclipse starts in Mexico, and the path crosses Texas and goes up to the northeastern part of the US and into Canada. So those are the eclipse maps that we want to share with you. And then back to the Texas map. You might have noticed that McDonald Observatory is not in any of these paths. We will be doing programs here at McDonald Observatory, but we'll also have a presence in the paths of those 2 eclipses. So, do you want to show us your eclipse, the interactive eclipse maps? Is that what we're doing?
Okay. Yes. So with this eclipse map, a really cool thing is you can actually type in the location you want to, where you're at, let's say, for example, and you can see how much of the eclipse you can see. So kind of as I zoom in, you can see along the blue line is where you'll be in the kind of this little area square that's highlighted, shadowed better yet. It's you'll be inside the eclipse path. And then from there, you can actually see what times you'll get the peak eclipse. If you're not in that main total eclipse, or in this case, the annular eclipse path, how much of the partial you can get, and similar. So I saw someone from that X-ray guy, that he's from Amarillo, Texas. So we're going to type in Amarillo. Also, apologies, my keyboard is kind of loud. I like the click-clack sound when I work. So Amarillo, Texas. So here we can see, going to make it a bit larger. That way you can see a bit more clearly. So in Amarillo, Texas, the mask amount that will be obscured, covered up by eclipsed, will be about 84.78%. So that's how much of the sun will be blocked out by the moon. The duration will be just under 3 hours, and the max will be at 1643 universal time. So in astronomy, like using basically our own time zone, which is universal time. That kind of helps make sure everyone stays on the same page. If we say something's going to happen at universal time, different people around different parts of the world know what's going on. And conversion wise, I believe is about a 7-hour difference. 5 hour?
5.
Okay.
5 hours. 5 hours different from Central Daylight Time.
All right, so in that case, I'll be in Central Daylight Time. This will be about 11:43 a.m. So you'll start getting the eclipse in Amarillo at about 10:15 a.m. At 11:43 is when you get the max amount covered up, and then it will completely end at about it'll be about 1:17 p.m. So you can also do it. You can type in where you want it to be, or you can just click. So let's say for Midland, Odessa, where it's going to be the big part of it, where Julie will actually be at to try to see it up close. And you see there's the star of the partial eclipse, star of the annular once the moon is as much in front of the sun as it can. The max will happen around 11:45. And even at the max, to give you an idea of just how much is being blocked out, it's still going to be about 99.5% of the sun will be blocked out. And that difference between 100% and 99.5 is really big. Oh, and these links will be later on posted will be added onto the comments of the Facebook stream and video, and will be added to the description of our YouTube video. That'll be added in after the stream. So y'all can check this out, because not only do we have one for the upcoming annular eclipse, we also have access to one for the total solar eclipse happening next year. So again, we'll do Amarillo. So for the eclipse happening in April of next year, so in Amarillo, Texas, the max you'll get coverage-wise will be about 84%. And that will be about 1:38 p.m. That's when you'll have the max amount of it. And even a cool thing you can check out, you can see just how far away, even being pretty far away from this, you can still get a portion. Like even in Seattle, they're still going to get at least almost 20% of the sun will be covered up by the moon. This goes pretty far. So from there, it can also help you out if you're planning to go to the eclipse. Now you can see what areas you will be at. Do recommend if you're planning to go, plan as far as advanced as you can. Some areas have filled up very quickly. Haven't heard some hotels, like one-star hotels, that are currently going at $650 a night along the path of the eclipse for those dates. So try to plan ahead, or if you have family in that path, might be a good time to go pay them a visit. So you can plan in advance. Yeah. I think with that next, so these eclipses are going to be really cool, and you're going to be wanting to see them. But as you probably know, the one thing we always tell you not to do with the sun is don't look at it. Do not look directly at the sun. Even with a telescope, the magnification of the telescope, that can just make it so much worse. But there are ways to safely look at the eclipse and the sun, which Joe will actually go over.
All right. Thank you, Saul. So, okay, here. Okay, so here we have some safe ways to view the sun with the telescope. The safest way is to project the image of the sun onto a piece of white paper or a piece of white cardboard. And you can also use filters that fit on the very end of a telescope. The different types, we have mylar filters, and we also have glass filters. Now, if you ever come across a filter that looks something like this, a sun filter, what these are is a piece of welder's glass that screws in on the end of an eyepiece. What happens is, what would happen is this concentrated sunlight could cause the glass to heat up and crack. You should never use one of these at all. If you find one or have one, I recommend you take it out and whack it with a hammer. Now, the first telescope I got when I was a kid, in fact, I still have it, it came with a sun filter like this. I admit I did use it for a bit before I learned I should never use it. So I quickly disposed of that filter once I learned it was unsafe. Now, if you want to view the sun, without a telescope, we have safe ways. We have, eclipse glasses that you can, use. You want to make sure you get those from a reputable source. You can also project the image of the sun with a device on the right-hand side. You can see a cracker we used here, projecting the sun through the holes in the cracker. And the reason the image is like a crescent shape is because that was during the total eclipse of the sun back in 2017. And those are crescent-shaped images as we're approaching the total phase of the sun. And there are other devices you can actually, make to view the sun safely with your eyes. We've made a bunch of them here for our programs. I want to show a couple. Well, we didn't make this one, but we have a little eclipse shade here, and this is mylar that's inside here, luminized mylar. And just look at the sun safely with this. A variation that we kind of constructed here is using some mylar sheets. We made you can put this over your head here, and you can look at the sun safely. You might look like a 1950s sci-fi robot or something, perhaps. So,
Joe,
yes,
that's not just mylar.
I know,
right?
It's not just mylar. Yes, it's a plastic shield that's over that too.
Well, right. But the material we added to it was specifically manufactured to be safe to look through at the sun.
Right.
I just want to say that I went to an eclipse years and years ago where somebody was using a mirrored mylar John Travolta poster as a solar filter. I think that's not one of the approved things.
Okay, all right, but this one is. This one is. Yeah, this is safe. Okay,
we made it. We should. Well, Barry, Joe, and Julie made it. So it's Joe and Julie certified.
Right.
JJ certification.
Correction on that. So, the one more safe way to view the sun, you can make using a cereal box like this. What you can do is cut the flaps off of the box and put some aluminum foil on one side. Poke a tiny pinhole in that aluminum foil, and this other side. You can position this to where the sun is behind you, and you can have the sun will project through the cereal box to the pinhole. Look in the box, and you will see a little image of the sun in your cereal box. So some safe ways to view the sun here. So, all right. So speaking of the sun, we are planning to view the sun with our telescopes today. We have some cloudy conditions this morning, kind of some rain showers in the area. So we won't be able to look at the sun with our telescopes. But I want to show you types of light we can view the sun in. And we'll be showing you pictures of the sun taken from other telescopes here in just a minute. So we have two types of light. We have, of course, visible light that our eyes can detect. We can also look at the sun in what we call hydrogen alpha light, a type of light that, the sun is made up mostly of hydrogen, So a very narrow wavelength of light. You can see many features on the sun using this wavelength of light. And our solar telescopes that we have here, they're housed in the structure, which is called a roll-off roof observatory for obvious reasons. Then we have 3 solar telescopes. Our main telescope is a 6-inch telescope. That's the diameter of the lens, used to view the sun close up in hydrogen alpha light. Then we have smaller telescopes on the side that are used to view the sun wide angle views of the sun in hydrogen alpha light and also in visible light. All right, so since we cannot look at the sun with our telescopes today, I'll bring up some pictures of the sun taken from other telescopes here. And Saul's going to talk to you about some features on the sun with these telescopes here. So let me give a minute here and I'll pull up those pictures here. Give me a second. Bring those up here. Here we go. So this picture is taken off of a website called spaceweather.com. And on this website, they update what's happening on the sun about every day and what else is happening in the sky. So Saul, tell us about what we're seeing here.
Yeah, so thank you, Joe. So as mentioned, this have from spaceweather.com. So this image is from the Solar Dynamics Observatory. So this isn't like a live view in terms of like this what's happening right now, but this was taken earlier this day. This is how the sun looked like as of this morning. I still see light coming in through my window, so the sun is still there and should still be looking this way. So one of the first things you might notice is one of the first things that people usually ask is like, where's the fire and stuff, like in pictures and videos, it's like fire going all around. So right now we're seeing the sun in that visible light. We can't really see these other formations. For right now with a visible light, one thing, there's something you might be noticing with the sun. So some people might say it looks like there's almost seems to be like a texture to the sun. So Joe, if you could zoom in a bit to kind of bring that texture
definitely
into view, please. Yeah, you see there's like all that kind of grainy texture. We call that granulation. That's how the sun's surface actually looks like. So this granulation is actually kind of caused by convection. The stuff in the bottom is heating up, rising to the surface, release all the heat and energy, cools down, and repeats itself. So you can see that technically all this granulation is kind of like if the sun's surface was bubbling, like if each of these granules were actually a bubble. And these bubbles are really big. So to give you an idea of how big it is, so those of you who are watching the stream from Texas, or have lived in Texas or driven across Texas, how long does it take to drive across Texas? Put that into the chat. Yeah, take a little bit with a little bit of the stream delay. Yep. Usually it's several hours. Some people say 8, 10, 12. Whereas this 8 hours is probably speeding. Answer I get a lot is it'll take a long time. 20 hours. Yep, 20 hours sounds like a pretty good length. 6 hours. Doug, you're driving really fast if it takes you 6 hours to drive across Texas. 24. Yeah, all of them are really good guesses and very real answers. Except I think with the Doug, well, I hope the cops don't see you when you're driving that fast. But it's gonna take us a really long time. Reason I'm asking this answer, asking this random question, is because each of the bubbles is about the size of Texas. These things are huge. And that gives you an idea of comparison of how big these dark spots we're seeing on the sun are. These dark spots are sunspots. They're areas of the sun that are cooler than the rest of the surface. If you're inside a sunspot, you'd be at a chilly 7,000 degrees Fahrenheit, so make sure to bring your jackets along. And even though the dark part of the sunspot seems very dark, the Umbra part, if you're to pluck out a sunspot, put into the night sky, it will outshine the full moon by almost 100 times. The reason it's so dark is the rest of the sun is really bright. Actually, a good example are cell phones or any tablets, anything with a screen. When you're indoors, you can see the screen just fine. Moment you step out into the sunlight, you can't really see the screen anymore. It's that competing light, but on a lot bigger scale. And to give you an idea of how big these sunspots are, Joe, would you say that sunspot on the left side is about the size of Earth, or bigger than that?
I think it's bigger. Let me zoom out here to get a better feel for this. I'm going to say it's a couple of times the size of the Earth or so.
Yeah.
Now,
So,
this sunspot group that's down, let me move over here. That one is probably perhaps Neptune-ish sized. What would you
wow.
think?
That sounds about right.
Okay.
Yeah, though these things get really big and also they grow and shrink over time. They're almost like clouds in terms of how they move and their shape
Right.
and such.
And
Uh,
for comparison, Neptune's 4 times the size of the Earth.
yeah, these are big.
Big.
The other thing you might be noticing, kind of that we're at this area, there seems to be some brighter areas on the sun. So we call these solar faculae. Basically, what's going on, the sun surface kind of parting a little bit, letting heat and energy from lower levels to seep on out. So you can see these are kind of like cracks on the surface. It's a temporary cracks. Thankfully, the sun isn't breaking. That would be very bad for us.
Mm-hmm.
Now, again, you might be wondering, well, that's like the fire and other things that you see in things. Like behind Julie in her solar picture, you see there's things slipping around along the sides. To see that, we actually need to see it in a different wavelength, in that H alpha filter Joe was mentioning. So for the H alpha view, it will be a bit more of a more recent image of the sun. So
Let me
where
bring
we're
that
going
up
to
here.
get from
So,
is from the NSO, and what it's basically, you can actually look it up. The spaceweather.com is accessible to the public, and the H alpha views we'll be pulling up are as well. You can just type in H Gong Alpha NSO and you can get it. So here's one taken by NSO and the NISP, National Solar Observatory Integrated Synoptic Program. And this was taken from Cerro Tololo in Chile. So this image is actually about 3 minutes old. That's how it looked like about 3 minutes ago. Now, first thing you might be noticing is the color's different. It's a black and white image now. Usually you use black and white pictures to tell apart details more easily on the sun's surface. One of the things you might be noticing detail-wise is there's no grainy pattern texture anymore. It looks wavy. And that's actually because we're looking at the hydrogen gas moving around. You'll see some features from last time, like the sunspots. The sunspots are still there, though maybe not as bright, as obvious as with the white light view. You also see some bright areas here. So these are actually a different thing. They're known as solar plages, so solar beaches. And they're really bright areas in the sun. Now, if the dark areas were cooler areas, the brighter areas are hotter areas. So the bright white parts are solar plages, very hot, very energetic. And sometimes if they're really bright or they're really prominent, we like to keep an eye on it because there might be something called a solar flare coming from it. Huge bursts of energy is released all at once. They seem to happen around these areas. It might be points of interest. You might also be seeing what look like clouds on the surface of the sun. We call these solar filaments. Sometimes the sun's material leaves the surface, loops around, and goes back in. Now you may be seeing there also seems to be some clouds along the edge of the sun. We call these solar prominences. Those are created when the sun's material leaves the surface, loops around, and goes back in. If you're thinking, well, why he just said the same thing twice, you're right. It turns out a solar filament, solar prominence, the exact same thing. Just view that from different angles. So they recently have different names is that we thought they were different things. We know that isn't true anymore, but the names suck, which is actually pretty common in astronomy. Anything that's causing these things, I saw Jamie Wolfell, apologies if I'm not saying your name correctly. What causes these? So what's causing like the solar prominence and the filaments and the solar plage, these bright areas, is the sun's magnetic field. So the sun's magnetic field is pretty wonky compared to Earth. So with your Earth magnetic field, I'm just going to use my little speaker here as an example. So with your regular magnetic field, it leaves the North Pole, circles around, goes to the South Pole. North to South, very nice, neat, and pretty. So since the sun's a big ball of gas, that doesn't really apply. When a solid sphere spins, no matter where you are in the sphere, it's going to take the same amount of time to complete one rotation, which for Earth is about 24 hours. Since the sun's a ball of gas, though, or more specifically a plasma, when it spins, different parts move at different speeds. We call this differential rotation. So we lived at the equator, the middle, taking about 25 days to complete a trip. At the poles, though, would take you about 35 days. Because of that, things get twisted around. The prominences, sunspots, and the field. So the magnetic field, the kind of going all over the place. Sometimes material catches onto the field, loops around with it, creating the filaments and the prominences. When the field enters a part of the surface of the sun, interrupts convection, the bubbling, creating the sunspot. And sometimes the field gets tangled up. It can get all tangled up, start to build energy. It gets more and more tangled, builds up more and more energy. That as that field's getting all tangled up and that energy's building up, we can see that being the solar plages. So basic solar plages, making a long answer to that question, solar plages, sun's magnetic field getting tangled up, building energy, getting hotter and hotter, and appearing as a very bright area on the surface of the sun. So yeah, and actually later on we could probably see if there's any of them been moving around. But for now, let's focus a bit more on the solar prominence. So, Joe, can you zoom in a bit on one of them,
Let's
please?
see, we're zoomed in as much as I can, but is that a good one to look at right here, say?
Oh, yeah,
There we
definitely.
go. Okay.
Oh, yeah, so for the darker areas of the sun, they are the cooler areas. So the magnetic field is causing that as well, but it's interrupting the bubbling, the convection, causing it to cool down and create the sunspot. So magnetic field getting tangled, build up of energy, gets hotter, will create a solar plage in this field of view. When the magnetic field interrupts the bubbling, convection, creates a sunspot. Yeah, I say zoom in a bit more if you can, Joe. If it's
Let's
possible.
see here.
Maybe like a
About,
Control Plus on the keyboard.
yeah, let's try that here. Give me a second here. Let's see here. There we go.
Yay, there it goes.
Better?
A little bit more.
A little more. Okay, let's do a little more here.
Enhance.
Enhance. Let's go to this big one up here. I like that one.
Yeah, that's a very nice one.
All right.
So with this, you can see. So how big do y'all think that prominence is in planet Earth sizes? Drop your guesses into the chat. So if you were to put planet Earth one on top of the other, how big would this prominence right here be? We'll give it a little
Waiting
bit.
for an answer here.
They shall arrive shortly. 5 Earths, very good guess. The size of Mount Everest, another very good guess.
Good guesses here.
Yeah. So kind of giving you a little bit of a hint. you all see there seems to be like a bright fuzzy layer around the edge of the sun? We call that the spicule layer. It's about half a planet Earth tall. So this prominence is about 5 times taller than planet Earth. Actually, Jamie, you're right on the money. I sadly have no prize to give out. That would be cool. We could give out like a little sticker or something like that. We would. Most I can give is a thumbs up. Because sadly, I would give a sticker if I could, or other prize. But yeah, it's about 5 planet Earths tall. We could fit right next to it. We could fit in it. Wouldn't be fun, but we could fit in it. And these also move very quickly and loop around. A little fun fact, we like to nickname them after plants. So there might be shrub prominences or tree-like prominences. Because where you look at the sun for hours on end, you have to find a way to detain yourself. Now, to kind of show off a bit more of the movement, something I pulled up from the same site is actually sometimes these telescopes can give us basically little videos of how the sun has been moving over the course of several hours. So this is still from the same site, H-Gong Alpha, and we're going to play a little time lapse they have. So I'm going to zoom in a bit more onto here, if I can.
That's nice.
Yeah. So you can see the prominences moving around, growing, changing sizes. And you see where the solar plages are. You see some of them are getting brighter and dimmer. If some of these had gone very, very bright all in one go, that could have meant a solar flare happened in the area. And there's a solar prominence here that gets really wild. There it goes. Ooh, it's a really cool one. Okay. Let's see. And these prawns can get to many sizes. Some can even get to about 40 planet Earths tall. So I think this would be a good time to ask if anyone has any questions. If you have any questions, feel free to drop them into the chat. I did see one. There's one earlier from Claudia Moreno about for the pinhole activity for the Zero Box viewer. Is there a tutorial for it? So there is. We actually have it on our website, McDonaldObservatory.org. Underneath the resources page, we have it linked to there. And also we have it from NASA as well. We can post that link into the description later on in our chat. But also it's available on our website, McDonaldObservatory.org.
Yes, so let me just clarify. What's available on our website is on McDonaldObservatory.org/eclipses. There is a link near the bottom that says Eclipse Education Resources, and that is a huge page of resources, and that includes the serial box. So we don't have the actual activity on our website, but we do have a link to it on that page. So it's a link and a link to get to it.
All right. Yeah. Thank you for the clarification.
Yeah.
So it's our website, McDonaldObservatory.org. You said was
/eclipses.
/eclipses. McDonaldObservatory.org/eclipses. I hope I spelled eclipses correctly.
I think it's eclipse singular.
Eclipse.
Sorry.
Eclipse not found.
There it goes. Yeah, eclipse not found.
Yeah.
Yes, we have lots of cool resources on here. And let's see. Yeah, lots of very cool resources in here for how to look at it safely, experiencing the eclipse, and eclipse education resources. So this has lots of very cool resources like the Zero Box Viewer and other similar ones.
So while we're on that page, can I say a word about Eclipse, the training for Eclipse hosts? Okay, so you see that button on there that says training for event hosts. If you are hosting an eclipse event, either in October or April, or at the next eclipse that crosses the US in 2045, we offer a training session. It's about an hour and a half. It's by Zoom. We send you a link, you join, and we teach you all about eclipses and some extra cool ways to safely observe an eclipse and some other things to think about if you're hosting an eclipse event. We've got lots of resources we want to share with you. And so you can sign up for that. We also have a mailing list you can sign up for, and feel free to avail yourself of the eclipse education resources because there is a ton of stuff on there. Okay. That's all I want to say about that, I think. We've gotten some questions in. Are you ready for some questions?
Yeah.
All right. Fred Hendricks says, can we discern any effect of flares and spots, or is the sun too far away?
Yeah, so we actually can. So when the flare goes off, we can actually get an idea of how strong that flare is and even get an idea of how long it'll take to get to us. So we actually have been able to get some really good views of the flares and the sunspots from ground-based telescopes and some base in space. NASA also has sent their probe a bit closer to the sun, and we actually can discern the effects they can do, not only just in terms of, hey, energy being released, but we can get an idea of how would that affect us here on Earth. And solar flares this strong might affect us this much.
What kinds of effects do we feel?
Yeah, so the way the flares affect us, they affect us in the electromagnetic sense. So basically, it'll affect things like radio waves, or can affect how instruments can work. I have programs before. I've had people say that they are ham radio operators, and they say during some of these they can talk to people all the way in Japan on their ham radio.
Mm-hmm.
And there have been effects in the past where we get a really big burst of this. It can cause some issues, such as in the 1800s, one called the Carrington event. Some people said some things are turned off, turned on again. And also, they are really strong. The sun, the energy being released by the sun, by kind of solar wind, the flares, when that interacts with our magnetic field, it also is actually what causes the northern lights. Our magnetic field captures some of the energy, sends it to the poles, sends it into the atmosphere, and causes the northern lights. So we get a big enough one, we can actually see them all the way down here in Texas. I think Joe and Julie, you've actually seen some northern lights down here. I haven't here. So Joe has at least.
I was asleep for that.
I was too. I didn't know until the day after. And I was like, "Did you see the northern lights?" I didn't know they were happening.
Yeah.
Ooh, so yeah. See, this other question here I can address. JB Awofel, I guess I pronounced that right. Her question here is, does solar activity change in its own kind of seasonal shifts? I actually have a slide to help illustrate your question here, Jamie. Let me bring up that slide here. Let's see here. Give me a second here, and I've got to take that slide up here ready to go. So here we go. Yeah, so the sun, it does go through a cycle of activity. Once every 11 years, the sun reaches a peak of activity, what we call solar maximum. Hovers there for a couple of years, then goes back down. And we are heading toward the next solar maximum here in, a year or so. So you can see on this graphic I brought up here, 400 years of observations of a sunspot activity here. And there is a period from 1645 to 1715 where there's hardly any activity on the sun. That was called the Maunder minimum there. So yeah, so the sun, it does go through a cycle of activity.
And you can sort of call that seasons on the sun.
Sort of, I guess.
But they're not like seasons
on the Earth. But I thought that might be a relative answer to her question.
Yeah. And then to answer Gabby asked, do we have some specific month when the sun is more active? And Gabby, it looks to me like the sun is more active on this 11-year cycle. However, the way the sun's magnetic field interacts with the Earth's magnetic field, the Earth actually there is an aurora season, and so folks who go to visit maybe Alaska or Norway for an aurora tour might go in the spring and the fall rather than the summer and the winter. So, but otherwise, the sun is more active on its own, and then that's kind of a separate thing. Does that make? Do you guys agree with that, or did I get it totally wrong?
Sounds good. Yeah.
Okay.
Yeah.
Agreed.
And then Randy wanted to know if there's any differences on the solar eclipses based on the season. No. It just depends on how cold it is where you are when you're watching an eclipse.
Yeah. Yeah, it does feel very chilly when the total solar eclipse does happen. It just
Okay, do you want to address Claudia Moreno's question?
Yeah.
Is that our last question, maybe?
I believe so, unless other people submit more. So Claudia Moreno asks, how is global warming related to solar activity shifts? So actually, global warming is not related to the solar activity. So these shifts, this 11-year cycle, they're completely separate. As I mentioned, the flares and such affect us more in the electromagnetic sense, like radio, northern lights, similar things. That goes with the solar activity as well. So global warming is kind of its own separate system. Kind of what's going on with global warming is the heat that gets to Earth makes its way into the atmosphere, but then can't really make its way back out. It gets trapped. Mostly it's carbon dioxide, the thing that traps it in. So as those levels increase, more heat gets trapped in. So it causes global warming, or a better way to phrase it is climate change, just because this whole temperature shift is going on. Some areas get hotter, some areas might get a lot colder than they should be. Just this excess of heat is messing up weather patterns all around. But the sun, it just gives us heat in terms, and the sun, this 11-year cycle only affects these energy bursts, but doesn't really change the sun's temperature. So they don't affect us in terms of climate change or similar.
Okay, thank you.
Okay, thanks.
And I think we've hit most of these excellent questions. So thank you very much for the excellent questions. You all have been wonderful to talk to, kind of virtually, but we feel like you're there with us, asking us hard questions that challenge us, and we like that. So thank you. What's coming up, Saul?
So things are coming up. So Cav, before talking about some of the things coming up, do you want to share there is some more resources you can use apart from just us at McDonald Observatory /Eclipse. There's also eclipse.aas.org and the greatamericaneclipse.com. Those are very good resources. Also, AAS also has some very good resources as well for like Eclipse viewers and other things, like certified vendors. Do make sure we're getting your Eclipse viewers from our certified. During the last eclipse, there were instances where people bought Eclipse viewers from Amazon or similar, and they were not up to standards, and people afterwards reported going to the hospital talking about that their eyes were really hurting, and it turned out they weren't using the right viewers for that. So do be very careful with that. Some things that are coming up, as mentioned, the eclipse in October is coming up, the annular eclipse, and we will be doing a live stream as well. This live stream will only be going on YouTube, but we'll be working with the Blakemore Planetarium. And if weather is favorable with us that day, try to show live views of the eclipse from here at the McDonald Observatory, and possibly also from Blakemore Planetarium, kind of showing both our partial view of the eclipse and their full annular view. It'll be a long stream, about from 10:15 a.m. Central Time all the way to 1 p.m., where we will mostly be doing activities throughout the stream, such as I will be creating a cereal box viewer live during that. So if you want to then build it along with me. And around peak eclipse time, we will be doing a more standard stream and showing off those live views with Julie and our colleague of ours, Rachel. And then we'll be connecting with them all the way out in Midland.
Yep.
Yeah. I think that's about it, unless there's any other information that y'all can think of that we should add in. All right.
I think that's it.
Yeah. Oh, one thing I also do want to say, if you want to go see the eclipses, it's better to go to the pass of the annular eclipse or to totality. Difference between a
Definitely.
99% eclipse and 100% is almost a night and day difference. It is a very cool experience. It's better to go to that area there to see that eclipse.
Yeah, especially the April 8th, 2024 eclipse, because the
Definitely.
next total eclipse whose path crosses the US after 2024 happens in 2045, and that is a long time.
Yeah. If you want to see it any sooner than that, you have to go all the way out to Europe. I think they have one like in the 2030s. I think it's the next one on Earth.
So just to answer Fred really fast, McDonald Observatory is open to the public at our visitor center. We're open Tuesday through Saturday, and we are going to be open during the starting at 10 o'clock on
Yes.
October 14th, right? So that people can come and observe, come and experience the partial eclipse with us at the visitor center, and we'd love to have you visit.
Yeah, coming out to see us.
Yep.
Yes.
Yeah. And well, with that, thank you all so much for joining us today. It was very fun to get to do this both on Facebook and YouTube. So hopefully y'all can join us again for any future ones. And thank you so much for joining and all your great questions.
Yep.
And hope y'all have a good day.
Take
Thanks
care,
for
everybody.
joining us. Have a
Bye-bye.
good day.
Bye.
Bye.